Assalamualaikum and welcome back. We are still on chain rules. Okay, here I'm going to show you another case where we have three intermediate variables and three independent variables. I'm not going to go through the formula here. I'm just going to go straight to the example. Okay, in the example, we're given a function w equals r squared plus s plus 2t. So here we have w is a function of three variables, which are r, s, and t. Excuse me. R is equal to x squared plus y squared plus z squared. You can see that here we have three variables, x, y, and z. So from R, we branch out to three branches, x, y, and z. S is equal to x, y, z. So again, we have three variables there. So S branch out to three variables as well, three branches, x, y, z. And T is equal to y, z squared. So for T, it branch out to two branches, y and z. Excuse me. So here you can see that on the far left, we have w. So w is what we call the dependent variable. In the middle, we have RST, so those are intermediate variable. And on the far right, we have X, Y, and also Z. So X, Y, Z are what we call the independent variable. So in this case, we have three intermediate variables and three independent variables. Okay, so now the question says, the question asks us to find first partial derivative of w with respect to x, y, and z. I'm going to show you only one of them. Okay, let's say we want to find partial w, partial x. Okay, so for partial w, partial x, you just look on the far right. You can see that we have 1x here, 2x, and that's it. So we only have two x's on the far right, which means that we have sum of two terms. Okay, sum of two terms. All right. Excuse me. Let's look at the first term. So first term, we have this x. So we want to go from this w to that x. So it has to go through r first. So the first term consists of partial w, partial r, and then partial r, partial x. For the second term, we look at the second branch of x. So we're going to go from this w to that x. It has to go through s first. So this is equal to the first branch, partial w, partial s, times partial s, partial x. And for t here, it doesn't have x, so we only have two terms here instead of three for y and z. Okay, so we only have two terms. All right, so now we need partial w, partial r, partial x, and ws and sx. All right, now let's look at partial w, partial r. Okay, for partial w, partial r, this is w. Excuse me. Excuse me. All right, so this is w. We want to differentiate w with respect to r, so we consider the other two variables, which are s and t, as constant. So partial w, partial r will give us 2r. And we also need partial r, partial x. Okay, so for partial r, partial x, this is our r. Differentiate with respect to x, so we consider y and z as constant, so that will give us 2x. Excuse me. And we also need partial w, partial s. Okay, so back to w, differentiate w with respect to s, so we consider r and t as constant, so that would be 0, 0, so we only have 1. And we also need partial s, partial x, so this is s, differentiate s with respect to x, we get y, z. Okay. All right, so now we're going to put everything together. So first term, partial w, partial r. So we have 2r. Rx is 2x plus partial w, partial s, which is a 1, and partial s, partial x, which is y, z. Okay, simplify this, we get 4rx plus y, z. And the last step is to replace the intermediate variables, if you have any, in terms of the independent variable. So we have intermediate variable term here, which is r. So we're going to replace that r with x squared plus y squared plus z squared. Still have x here, and then y, z. So this is the final answer for partial w, partial x. Excuse me. We're gonna save partial w, partial y, and partial w, partial z in our live class. Thank you.